Hey folks, welcome to this first lesson of this course on Java Web Services for beginners, in which I am going to introduce you to web services and its benefits. I will also talk here about the different kinds of web services. At a conceptual level, a service is a software component that is available over the network to process and service requests for other software applications. Web service is a client-server application that communicates over network protocols like HTTP. The application that sends the request is called as the consumer or web service client, and the web service is referred to as a provider. The service consumer and provider use standard messages to exchange information. These messages are agnostic or independent of the programming language of the consumer and provider applications, and created using standard formats like XML, which implies that the applications involved can be from any programming language, which provides true interoperability, as you can see in the diagram as well. If you don't know XML already, don't worry, I will cover that as well in one of the sections of this course. A good example of a web service can be, for example, a vehicle check application. For this example, let us assume it is coded in Java and it returns all vehicle details for the provided vehicle registration number. And different client applications written in any programming language like ASP.NET or C# or PHP can send vehicle registration number to this vehicle check web service. And this web service will process the request and return back the details of the vehicle for which the registration number was sent by the client. One of the characteristics of a true web service is that it is created in a way that there is loose coupling between consumer and web service. We have loosely coupled applications when changing one of them does not warrant a change in the other. For example, in a real-world example, tires are loosely coupled to the car. We can easily change the tires without making changes to the car itself. Similarly, in the vehicle check service example, if there are any changes to the way vehicle checks need to be done in future, then only making changes to the web service should be enough, and consuming applications should not need to make any changes in their code. Now let me quickly clear up the difference between web services and SOA. You might have come across this term SOA, which is an abbreviation for Services Oriented Architecture, and some of you might have wondered the difference between a web service and a SOA. So SOA, or Services Oriented Architecture, is an architectural pattern that makes possible for web services to interact with one another independently. So it is in other words, an orchestration of different web services, whereas web service is a realization of SOA concept that leverages technologies like XML or JSON, etc., and common internet protocols such as HTTP. Let us try to understand, why do we really need web services when we can still create great applications without them? There are many benefits using web services, and so many organizations are re-architecting their existing monolithic applications in silos to carve out web services from them. Firstly, web services enhance the reusability immensely. They are used to create self-sustained, reusable components like currency conversion, weather reports, language translation as services. Next, web services help to solve interoperability problem. With web services, you can exchange data between different applications running over different technologies and platforms. For example, a web service can be developed in Java running on a Linux platform, whereas it can be consumed by application developed using .NET technologies running over a Windows environment. And then they also help in seamless integration of applications. Suppose we are a provider of a service, say, for example, a weather forecast service, and we make weather data available for other applications. Then what is the need or why to make that information available in the form of a web page and then make developers of other applications who need that data to visit our website, scrap our page, and then extract the data that they need? Will it not be easier to develop a web service to which a developer can pass in a date and get back a well-defined XML document containing all the info they need? So this might help you appreciate the real need of a web service. Then another advantage of web service is that the web services can collaborate in a loosely coupled way to achieve complex operations. Programs providing simple services can interact with each other to deliver sophisticated added value services. This is a huge advantage for a business, as you might imagine. Now let us understand the two kinds of web services which can be distinguished as big web services and RESTful web services. At this point, I will talk about conceptual details, but later I will take you through actual implementation and create both the big and RESTful web services. Big web services use XML messages that follow the XML RPC or Simple Object Access Protocol standard. These are primarily XML language defining a message architecture and message formats. In other words, services based on XML protocols, XML RPC and SOAP. For those of you who are not familiar with RPC, it stands for Remote Procedural Calls. In legacy programming languages, methods were referred to as procedures, and that is why this name, to invoke remote or not local procedures. We will cover details of these XML protocols in later section. Now coming on to RESTful web services. REST is an architectural style which is based on web standards and the HTTP protocol. Because REST is based on HTTP as the communication protocol, which is stateless client-server protocol, the REST style also follows stateless client-server architecture. In REST-based architecture, everything is a resource. These resources can be text files, HTML pages, images, or dynamic business data, which in more technical terms can be said as that REST allows resources to have different representations. Example, text, XML, JSON, etc., which also means that REST supports MIME types like XML, text, JSON, and user-defined. For those of you who are not familiar with what is MIME type, it is nothing but a way to tell about the type of data that file holds, so that the software handling the file uses appropriate handling, just like if Windows identifies if it is a PDF file to open with Acrobat Reader. Every resource should support the common operations of HTTP protocol. REST server simply provides access to resources, and REST client accesses and modifies the resource. Here each resource is identified by URIs. So to help you understand what is URI, I'm pretty sure you all would already be knowing what URL means. a very common example of which is http www.google.com. So URI, if simply explained, is a superset of URL. So all URLs are URIs, and additionally, if we remove HTTP from the URL and have only google.com, it would also be a URI. In layman terms, if we have the name and address of a person, then name alone is also a URI, and name with the address, which would now become a URL, is also a URI. I would now conclude this lecture and hope this lecture would have helped you develop some high-level picture of a web service and appreciate the need for a web service, and also understand at a high level different types of web services, which are big web services and RESTful web services. I'll obviously take you through these different web services in depth in later lectures. So folks, bye for now and see you in the next lesson. Hi folks, I am Rochak Shastri and welcome to this course on Java Web Services that targets to enable you to develop various kinds of your own Java web services from scratch and also make optimum decisions on which one or which type of web service to use in a particular scenario. I myself have been programming Java and Java EE applications since the year 2000. When I started at that time, Java was still catching up, and I am glad that I trusted it for my living because it is now the most widely adopted programming language for new projects, and the demand for Java skilled developers steadily continues to grow. These softwares that I developed in the last 17 years were truly complex and challenging, which has helped me grow myself as a thorough professional in this technology. I had been providing formal trainings to new developers in my organization and mentoring junior team members in my team. Now this is my attempt to make my learnings available to a much wider group by way of online video courses on one of the very relevant skill in today's job market, which is Java Web Services. By the end of this course, you should expect to have developed solid skills on Java Web Services with all the concepts and practice required to start developing real-world Java Web Services, which would include both SOAP as well as RESTful web services. Also, I shall be covering different technologies like CXF to develop web services. Before taking a dive into the course, it is also important to understand why a course on Java Web Services makes sense. As we know that Java is still the most popular programming language even after 20 years of its existence, and will not be very easy for any other programming language to replace that as more and more applications continue to be developed in Java. Web services help eliminate the tight coupling between applications and also between various functional pieces of a application. When the application or parts of an application are loosely coupled, it enables each application to be modified without the need for the integrating application to be changed. This is a huge benefit for current world enterprises because of the rapid pace at which the business requirements change. Because web services provide this architecture, the demand for web services has grown and shall continue to grow in the future. Another huge demand by companies is interoperability, which means that their existing applications can talk to new ones being coded in Java without the need to migrate existing applications to Java, and web services gracefully enables this interoperability. So we can safely assume that there will continue to be a lot of action in Java Web Services domain. Another reason for Java Web Services is that modern frameworks like Spring Boot are simplifying the web service development immensely, which is leading to great reduction in developers' effort and rapid development of web services. Java Web Services is very focused area within Java development, and generally I have seen developers taking up web services development a little later in their career. So I have created this course to help those Java developers who still are in their initial journey on Java development to turn into strong web services developers too. Having such developers in mind, I have included fundamental concepts on topics not only relevant to web services but also underlying technologies like XML, JSON, JAXB. I have tried to create it pretty comprehensive and relevant to current industry skill demands like Apache CXF and RESTful web services. I will give you quite a few coding demos on creating web services and ask you to do a number of exercises which would give you a good hands-on practice on developing web services during this course. I think this should be a pretty comprehensive course that covers pretty much of all the knowledge you will need in your web services projects. After this initial introduction, I will start the first lecture by giving you an introduction of web services and their advantages and also the different kinds of web services. So folks, bye for now and look forward to see you there. Welcome back folks and glad to have you back. In this lecture I shall help you understand XML and XML namespaces. In case you are already familiar with these topics, please feel free to skip this lecture and move to the next one, in which I will be taking you through XML schema language or XSD and XML protocols like SOAP and XML RPC. So folks, what is XML? XML stands for Extensible Markup Language, and XML was originally designed to store and carry data, not to display data. XML tags or elements are not predefined by XML standard. We must define our own tags or elements and structure based on our needs. XML simplifies data transport. One of the most time-consuming challenges for developers is to exchange data between incompatible systems over the internet. Exchanging data as XML greatly reduces this complexity since XML can be read by different incompatible applications. Now let me show you a simple XML document as an example. As you can see here, an XML document is a tree. It has a root node that contains various child nodes. Some of these child nodes have children of their own. Others are leaf nodes that have no children. You can also see here siblings. There are mainly 5 different kinds of nodes in an XML tree: root, element, root, then element, then text node, and attribute node, and a comment node. Every XML document has at least one element. We cannot write XML documents without using elements. Now let us look at XML syntax and its rules. All XML elements must have a closing tag, and XML tags are case sensitive. XML element is everything from including elements start tag to including elements end tag. An element can contain other elements or text or attributes and or a mix of all these. Elements must be properly nested. XML documents must have a root element. XML attribute values must be quoted, that is in quotes, surrounded by quotes. In XML, few characters are illegal such as ampersand, so we need to use something called entity references, which in case of ampersand is ampersand AMP semicolon. In this example, online video courses and course tags have element contents because they contain other elements. Title element has text content or text node because it contains text. Course content also has an attribute category, and value of category attribute is software. Attributes provide additional information about an element. Attributes often provide information that is not part of the data, but additional information about the data itself, and then it is called as metadata in technical jargon. Attribute values must always be quoted by either single or double quotes can be used. Both single and double quotes are fine. If the attribute value itself contains a double quotes, you can use single quotes, like in this example. Or you can use character entities in the next example here by using ampersand quote, semicolon. Attributes have their own issues. Attributes cannot contain multiple values, but elements can. And attributes cannot contain tree structures, but elements can. And also attributes are not easily expandable for future changes. We need to understand these differences between elements and attributes because when we are creating an XML, there is always a confusion whether to keep some information as an element or an attribute. So for these reasons, as a best practice, elements should be used to store data, whereas attributes should be used for metadata. For example, in which category the course belongs to is an additional information. Like if this was a physical book, it could be that you keep in a software shelf or any other shelf, or whether the course is published on Udemy or any other portal is also an additional information about the course. But it is not an information which is a very much integral part of the course, like something like instructor. Now coming on to another important topic within XML, and that is XML namespaces. XML namespaces provide a method to avoid element name conflicts in XML. Elements are defined by developers. This often results in a conflict when trying to combine XML documents from different applications. Let us go to Eclipse to understand it better. So now I'm in Eclipse and I first create a XML file to represent a HTML table with rows and columns. Give it a name of HTML table.xml. So the first line that you see here, because I chose the extension as .xml, or the type of file that I created is as an XML file, so Eclipse has put a XML declaration. So the purpose of an XML declaration is for any processing code that is processing this XML file identifies this as an XML by looking at that declaration, including the Eclipse IDE. The first element that I add is a table element in this XML. Then I add tr element. And a couple of td elements or child elements. And apples and oranges that you see here, they, as you would have understood, are the text. I create another XML file that represents a coffee table. Give it a name of coffee table.xml and do finish. So the XML XML declaration is again put as the first line by Eclipse IDE. I start with a table element, and as you see that when I am putting an element, Eclipse automatically inserts the closing element. Add some child elements to the table element like name and size. Control Shift F to format as an XML file. So now I am going to combine both these XMLs to depict to you the conflict that arises. So I copy this the XML within the copy table.xml and put within the HTML table. So consider this as a concatenated file, a new file having both the XML files merged into a single file, HTML file. I add a root element at the top. So now you see the conflicts that arises. There are two table elements and each of them have different content and meaning. If there is an XML parser that processes this XML file, it won't understand the difference between these two. It will treat both of them as a table elements. So how to resolve the name conflict? Name conflicts can easily be avoided using a name prefix. So I put a H colon prefix for all the elements for the HTML table and a F colon prefix for all the elements of the coffee table. Now the prefixes added here will not conflict because the two table elements have different element names. One is a H colon table and the other is the F colon table. And both the table elements can be in the same XML file now. When using prefixes in XML, a so-called namespace for the prefix must be defined. And the namespace is defined by the XMLNS attribute. And that's what I am going to demonstrate to you now. How to use XMLNS attribute for namespaces. Namespace declarations are added like this by adding XMLNS colon prefix equal to URI to the top element of the XML. So I am adding to the H colon table element, and similarly I add XMLNS attribute but pointing to a different URI. Give it any notional name as URI2 this time. The namespace URI is not used by the XML parser to look up information. The purpose is to give the namespace a unique name. However, often we use the namespace as a pointer to a web page containing namespace information. To simplify, we can also have all the namespaces as part of the root element of the XML so that they are not scattered across within the XML document. This approach makes the XML document more maintainable for future changes. and someone looking at the XML can easily make out what all namespaces are being used in this XML document. Another improvisation within XML namespaces is default namespaces. Defining a default namespace for an element saves us from using prefixes in all the child elements. It has the syntax of XMLNS equal to namespace URI. So I have applied the default namespace to both the table elements, and if we do it in this way, then we don't need to prefix the elements. I'm removing all the prefixes. Looks like I have made some syntax errors, so the Eclipse is complaining about that. I have removed the slash from the closing elements. Looks like all good. So now you see how we can use namespaces and default namespaces. Now an exercise for you to apply basic and XML and namespace knowledge that you have gained just now. So you have to create an XML file in Eclipse IDE that stores the favorite food and also favorite games or hobbies for each of your friends or family members. Then assign each of the two categories of food and games favorites in two different default namespaces. So folks, I am at the end of this lecture now, and to quickly summarize, in this lecture we understood XML and XML namespaces. In the next lecture we would take a look at XML schema definition or XSD and XML protocols. So folks, bye for now and look forward to see you in the next lecture. Welcome folks, and glad to have you back. In this lecture I shall help you understand XML schema language, or more commonly referred to as XSD. Also I will provide an overview on XML protocols like XML RPC and SOAP. Now let us jump to another core topic on XML, which is XML schema definition or XSD. I shall help you understand what it is really and why to use XML schema at all. As the name suggests, XSD or XML schema defines the structure of an XML document. Remember here that it is important to get an understanding of XML schemas to understand web services better. The purpose of a XML schema is to define the legal building blocks of a XML document. So an XML schema defines elements and attributes that can appear in a document. XSD also defines which elements are child elements and the order and the number of those child elements. XSD may also define whether an element is empty or can include text, and defines data types for elements and attributes. It may also define default and fixed values for elements and attributes. All XML documents that reference any schema must conform to the schema definition. When we can create XML without their schema definition, so why do we really need XSDs? Is it not an unnecessary overhead? Let me help you understand real advantages of having XML schemas. One of the greatest strengths of XML schemas is the support for data types. With support for data types, it is easier to describe allowable document content, data formats, and restrictions on data. And as you can guess, it is easier to validate the correctness of data. Another great strength about XML schemas is that they are written in XML, which means that we don't have to learn a new language, and XML parsers can help to parse schema files as well. And we don't have to learn any other transformation language like XSLT that we write for XML. Because XSDs are also XML, so XSLT will do the same job for XSDs as well. Because using XSDs, we can not only define data type but data format as well. It is extremely useful in a number of situations. For example, a date like 03/11/2004 will in some countries be interpreted as 3 November and in other countries as 11th March. However, if the XSD defines that data type date requires the format YYY -MM -DD, XML elements with a data type like this, date type equal to date 2004-03-11 date element closed, ensures a mutual understanding of the content. Another advantage of XSDs is that XML schemas are extensible. Because they are written in XML, within extensible schema definition, we can reuse a schema in other schemas and also create our own data types derived from the standard types, and multiple schemas can be referenced in the same document. Let me now share XSD built-in data types. Most of the data types are same as in Java. You might already have understanding about as a Java developer, like string, byte, short, int, long, float, double. And you see here integer type as well. So this integer type represents a signed integer. Values may begin with an optional plus or minus sign, and as we see here that int and integer data types both are supported. So what really is the difference? Int is 32-bit whereas integer is unbounded. So XML to Java compiler generates integer wrapper class object, and for integer data type it generates big integer data type. In actual practice, I would suggest that you use int and not integer. If you want to store even bigger numbers, use long data type. Decimal data type is any base 10 fixed point number. There must be at least one digit to the left of the decimal point, and a leading plus or minus sign is allowed. Examples are like 4 to 42 and minus 3.1459 plus 0.004. The difference between decimal and float is same as what I mentioned for int and integer. So better use float instead of decimal. Boolean data type. Representations of true are either true or 1. False can be denoted as either false or 0. Date data type represents a specific date. Date time data type represents a specific instant of time. It has the format of the date data type with characters added to support hour, minute and seconds, like HH, :mm, SS, and we may optionally also add time zone suffix to it. There are a few additional data types like token, name and ID. Token data type is for the values of this type represent tokenized strings. They may not contain new line or tab characters. Name is a name as defined in XML standard. The first character can be a letter or an underscore, and the remaining characters may be letters, underscores, digits, hyphens, period, or colon. ID data type is a unique identifier, as in the ID attributes type from the XML standard.
QName is an XML qualified name such as XSL style sheet.
There are various XML protocols, and some of the XML protocols are based on custom XML applications, whereas some use standard formats like XML RPC and SOAP. XML RPC is a pretty generic protocol allowing the transmission of method calls and arguments to remote systems that invoke these methods and return a value. XML RPC is a remote procedure call protocol that works over the internet. That is remote procedure calling using HTTP as the transport and XML as the encoding. It's a specification and a set of implementations that allows software running on disparate operating systems running in different environments to make procedure calls over the internet. An XML RPC message is an HTTP post request. Let me go to Eclipse to demonstrate an example of sample XML RPC request and response. To SOAP protocol, which is a refined version of XML RPC. SOAP is the most generic of all XML protocols, allowing the exchange of XML elements of a arbitrary complexity which may or may not be treated as method calls and arguments. SOAP is a W3C recommendation, XML-based extensible protocol to let applications exchange information over HTTP. SOAP is a much more robust protocol than XML RPC. It is much better designed from an XML standpoint as well. It takes advantage of numerous features of XML such as attributes, Unicode, and namespaces that XML RPC either ignores or actively opposes. XML RPC is adequate for simple tasks. Although there are some basic services available using XML RPC, the future clearly lies with SOAP. The key idea of both SOAP and XML RPC is that you can pass an XML document over the web using HTTP post. The exact format of the data does not really matter much as long as both client and server agree on what it is and what it means. XML protocols allow widely distributed systems to communicate with each other over standard HTTP. These protocols have many advantages compared to traditional RPC systems such as CORBA and RMI, including simplicity, transparency, and platform independence. Quickly summarize this description of SOAP. SOAP stands for Simple Object as Access Protocol. SOAP is a communication protocol between applications. SOAP is a format for sending and receiving messages. SOAP is language platform independent. Why is SOAP really so popular? Applications may communicate using RPC between objects like DCOM and CORBA. RPC represents compatibility and security problems. SOAP provides a way to communicate between applications running on different operating systems with different technologies and programming languages. A better way to communicate between applications is over HTTP because HTTP is supported by all browsers and servers, and SOAP was created to accomplish this. So folks, now it is time to look at SOAP building blocks. SOAP is an ordinary XML document containing the following elements. An envelope element that identifies the XML document as a SOAP message, and this element is mandatory. Then we have the header element that contains header information. This is an optional element. A body element that contains call and response information. Body element is a required element of a SOAP message. A fault element containing errors and status of information. This is an optional element. All the above elements are declared in the default namespace for the SOAP envelope, which is at w3.org/2001/12/SOAP-envelope, and the default namespace for SOAP encoding and SOAP data types is at slash 2001 slash 12 slash soap encoding. Let us understand about these elements in a little bit more detail. I have included an example soap message on the right side of the screen. As we saw that soap envelope element is the root element and a mandatory one that declares that this is a soap message. Note that XMLNS colon soap namespace in the soap message here. It should always have the value of http w3.org slash 2001 slash 12 slash soap envelope. This namespace defines envelope element as a soap envelope. If a different namespace is used, the application generates an error and discards the message. The encoding style attribute is used to define the data types used in the document. This attribute may appear on any SOAP element, and it will apply to that element's contents and all child elements. Next is the optional SOAP header element, which contains application-specific information like authentication, payment, etc. about the SOAP message. If the header element is present, it must be the first child element of the envelope element. All immediate child elements of the header element must be namespace qualified, as we see here in the example. The attributes defined in the SOAP header defines how a recipient should process the SOAP message. The must understand attribute can be used to indicate whether a header element is mandatory or optional for the recipient to process. The actor attribute is used to address the header element to a specific endpoint. A SOAP message may travel from a sender to a receiver by passing different endpoints along the message path. However, not all parts of a SOAP message may be intended for the ultimate endpoint. Instead, it may be intended for one or more of the endpoints on the message path. Next is the mandatory SOAP body element that contains the actual SOAP message intended for the ultimate endpoint of the message. Immediate child elements of the SOAP body element may be namespace qualified, as in the example here. Note that the M colon get price and the item elements are application specific elements, and they are not part of the SOAP namespace. Next is the optional SOAP fault element, which is used to indicate error messages. If a fault element is present, it must appear as a child element of a body element. A fault element can only appear once in a SOAP message. The SOAP fault element has the following sub-elements. As also included in the example message, fault code is a code for identifying the fault, and fault string element is a human readable explanation of the fault, and fault factor element has information about who caused the fault to happen. And finally, the detail element or the sub-element of SOAP fault element holds application specific error information related to the body element. So folks, this concludes my lecture on XML protocols, and we understood majorly about SOAP because of the several advantages it has over XML RPC. In the next lecture, I will help you understand about something called Web Services Description Language, or more commonly referred to as WSDL, or it is also commonly pronounced as WSDL. This is an integral part of web services and is a set of definitions that describe a web service. So folks, bye for now and look forward to see you in the next lecture. Welcome back folks, and glad to have you back. So far we have done all the groundwork to take a dive now into real web services development. In this lecture, I will cover big web services and more specifically SOAP web services. As stated in earlier lesson, big web services use XML messages that follow XML RPC or SOAP protocol, which is the abbreviation for Simple Object Access Protocol. Here I shall help you understand SOAP-based web services because SOAP is the standard protocol used across industries for developing web services.
Then I will also introduce to Web Services Description Language or WSDL and look at all the key elements of a WSDL file.
Now let us look at the merits of big web services and what are some of its drawbacks. Because SOAP uses XML, SOAP is platform and programming language independent, which means that SOAP messages can be exchanged between applications on different platforms like Windows and Linux, and also different programming languages. Thirdly, because SOAP runs over HTTP protocol, it does not face firewall issues. So it can travel unobstructed over the firewall. SOAP is simple to implement for developers compared to other integration technologies like RMI or Corba. Now, what are some of the issues with SOAP? The first one I feel is that SOAP messages are stateless. It means that two requests from a client to a web service are treated as distinct by a web service. And SOAP clients do not hold any stateful references to remote objects. Because SOAP are based on HTTP protocol, that's why the messages here are stateless, because as you might already know, HTTP is a stateless protocol. Secondly, because SOAP uses XML, it is relatively slow in terms of performance when compared to RMI or Corba. Thirdly, SOAP specification contains no mention of security aspects. There are a couple of design approaches that are used to implement big web services: contract first and code first, or also known as contract last. In the contract first web service, the contract, which as I mentioned earlier is the WSDL, having definition of operations and endpoints, and XML schema of the messages is created first, without actually writing any service or Java code, which is actually, in other words, implementation of that contract. In the code first web service, existing logic or Java code is exposed as a web service and the contract is created at the very end. Now let me share some of the reasons that can help you decide in what situations you should go for contract first and in which ones code first approach. In contract first approach, we first design and freeze the contract of the service before development. There are very less chances of further changes to the contract. This approach also allows us to work on the contract by allowing functional people like business analysts to finalize the service contract without developing the actual service. And we can define a schema detailing service messages in separate files. Defining your schema in separate files also allows for reuse of schema file in different scenarios. And there is one more important advantage of contract first approach. Even though a contract must remain unchanged for as long as possible, but it can be changed sometimes due to some business needs. This approach allows for looser coupling between contract and implementation. This is a huge advantage. Such looser coupling allows us to implement both versions of the contract in one class. The code first approach provides one major advantage, that overall it is easier to implement because in the initial stage no WSDL skills are required.
Now let me help you develop a good understanding on WSDL.
So WSDL is an acronym for Web Services Description Language. As mentioned, it is an XML file that describes a web service to someone who wants to understand how to integrate with the web service. So WSDL is also part of is sort of a contract between web service and client. WSDL is also used to locate web services. Now let me explain you the various XML elements of a WSDL file. I also have here the WSDL skeleton that helps you visualize at the same time as we are talking about the different XML elements. Before I begin here, you might find understanding all the elements a bit overwhelming, but don't worry, you will never need to create all this yourself from scratch. Like in Eclipse, we can generate the skeleton with all the elements and then customize it based on our need. As you can see here, definitions must be the root element. It defines name of the web service and various namespaces that are used for this WSDL. As mentioned in the namespaces lecture, it is important that you provide unique values to namespaces even if they don't exist at the location you specify. WSDL at a high level has following key elements: types, message, port type, and binding. A WSDL has a number of other elements, but they are contained within these four main elements. These may all be developed separately and then clubbed or reused later to form complete WSDL files. Now coming on to the types element. As you may imagine, a web service needs to define its inputs and outputs and how they are mapped into and out of the services. The types element fulfills this use case. Types element defines all the data types that are used between client and the web service. For maximum platform neutrality, WSDL uses XML schema syntax to define data types. Next we have the message element. The message element defines the data being exchanged between the provider and consumer. Each web service has two messages, input and output. Each message can consist of one or more parts. The parts can be compared to the parameters of a function call in a traditional programming language. Then we have the port type element, and port type element combines the different messages defined in the message element that we just discussed to complete the round trip operation. For example, as most commonly done in SOAP web services, one request and response can be combined into a single operation. So port type element effectively is for describing a web service, the messages that are involved, and the operations that can be performed. The port type element can be compared to a function library or a module or a class in a traditional programming language. WSDL defines four types of operation types. The request response type is the most common operation type, and having this type, the operation can receive a request and will return a response. Then next we have other operation types like one-way, solicit response, and notification. In one-way operation type, the operation can receive a message but will not return a response. With solicit response operation type, the operation can send a request and will wait for a response. And finally, with notification operation type, operation can send a message but will not wait for a response. Now coming on to the final key element, which is called binding. The binding element provides specific details on how a port type operation will actually be transmitted over the wire. The binding element is for WSDL bindings and defines the data or message format and protocol for each port type. That is, WSDL bindings defines the message format and protocol details for a web service. Bindings can be made available via multiple transports, including HTTP GET or HTTP POST or SOAP. Let us look at this example here. As we see here, the WSDL binding element has two attributes, name and type. The name attribute defines the name of the binding, and the type attribute points to the port for the binding, in this case the payments port. As we see here, I am making available this binding via SOAP and not HTTP or POST. I mean HTTP GET or POST. The SOAP binding element has two attributes, style and transport. The style attribute can be either RPC or document. It indicates the overall style of the message format. Document file format is the text or binary format to store documents. RPC format is generally used for something like crystal reports. In this example, I am using document, which is what we normally need to use in our WSDL files. The transport attribute defines the SOAP protocol to use. In this case, we use HTTP. It may also be something else like SMTP protocol also. The operation element defines each operation that the port type exposes. For each operation, the corresponding SOAP action has to be defined. We must also specify encoding style of input and output messages. In this example, I am using literal, which is the most commonly used style, and as you might already know, literal means any constant that can be assigned to a variable. A WSDL document can also contain other elements like extension elements and a service element that makes it possible to group together the definitions of several web services in one single WSDL document. So folks, I hope this should have helped create a strong understanding about WSDL and contract first and code first design approaches. So folks, bye for now and look forward to see you in the next lecture.
Now let me help you understand about build tools and specifically about Maven. To be able to appreciate this, you should have some experience of programming and also compiling your code. Build tools are programs that automate the creation of executable applications from source code and also automate all the steps required to build a software project. For example, jar for Java or .apk for Android app. Building a software project typically includes one or more of the below activities. Compiling source code, that is compile Java source code files into Java classes. Packaging compiled code into jar files or var or EAR or zip files. Then generating documentation from the source code. And finally installing the packaged code on a server or in a repository or somewhere else. There are more than one popular Java build tools available like Ant or Maven or Gradle. But for this course I am going to use the widely adopted tool Apache's Maven. Maven is a comprehensive build tool that provides developers a complete build lifecycle framework. Development team can automate the project's build infrastructure in almost no time, as Maven uses a standard directory layout and a default build lifecycle. Then using Maven we can manage any dependencies such as jar files of any framework like JDBC drivers required in your project or Tomcat container required to run your application, etc. And also using Maven we can create documentation for our source code and also generate test cases reports such as how many test cases have run along with their results, etc. I understand that new developers might get overwhelmed with all this language, but I will simplify all this when I actually demonstrate very soon. And for those of you who still find it difficult to grasp after this lesson, I would strongly suggest that you watch this lesson after the last lesson again, and then I am sure you would truly appreciate it. I have included it at this stage because this is the first thing you need to do if you use a Maven web project to create your apps. And the reason we use Maven web apps project because it simplifies your life in many ways and helps in rapid development. Let us now dive a little more into Maven. Maven works around the concept of POM, or Project Object Model files. A POM is an XML file which contains a representation of project resources like source code or test code and dependencies such as external jars required to build application, and is also a representation of servlet container like Tomcat, which is the server on which we will deploy our web application. The POM contains references to all these resources. The POM file should be located in the root directory of the project it belongs to. Here is a diagram illustrating how Maven uses the POM file and what the POM file primarily contains. So Maven first reads pom.xml and then downloads dependencies into local repository if it does not find in the local repository, and then executes life cycles and build phases and or the goals, and then it executes the plugins. All the above executions happen according to the selected build profile.
Now let us understand Maven build process to help us know more about its execution. The build process in Maven is split into build life cycles, phases, and build goals. Maven build lifecycle consists of a sequence of build phases, and each build phase consists of a sequence of goals. When you run a Maven command, the command may be the name of a build lifecycle or a goal. If the command name is for a lifecycle, then all build phases in that lifecycle are executed. If the command name is for a build, then all build phases before it in the predefined sequence of build phases are also executed. Standard life cycles are clean, build, and site. Build is the default life cycle, which means that if you don't specify any life cycle in your command, this is the one that will be executed. Example of a build process is, as you can see here, the predefined clean lifecycle executes pre-clean, clean, and post-clean phases, which executes different goals like clean goal.
Now, assuming that you have basic understanding of XML, let me now describe the elements of pom.xml file and start with the main elements. Project root is the root element of POM, and model version should be set to 4.0.0. Now coming over to the elements in the basics section. The group ID element is for specifying the ID of project's group. Artifact ID element is the ID of the artifact, that is the project, and version element is for the version of the artifact under the specified group. A POM requires that its group ID, artifact ID, and version be configured. These three values form the project's fully qualified artifact name. A project's fully qualified name is in the form of group ID, artifact ID, version. Next, coming to the packaging element. If the configuration details are not specified, Maven will use their defaults. One of these default values is the packaging type. Every Maven project has a packaging type which can be POM, jar, var, EAR. If it is not specified in the POM, then the default value jar would be used.
Now coming over to dependencies elements. As I mentioned earlier that one of the key roles of build tools is to manage dependencies. One of the first steps Maven executes is to check the dependencies needed by your project. Dependencies are external jar files or Java libraries that your project uses. If the dependencies are not found in the local Maven repository, Maven downloads them from a central Maven repository and puts them in your local repository. The local repository is just a directory on your computer's hard disk. You can specify where the local repository should be located if you want to. And you can also specify which remote repository to use for downloading dependencies. All this can be controlled through settings.xml file that we will look at shortly. Dependencies are specified with project's fully qualified name. When you specify your dependencies, you also need to specify their scope. There are 5 scopes available for dependencies. First one is the compile scope, which is the default one. It is used if none is specified. Compiled dependencies are available in all class paths. Next type of scope is provided. So provided is the name of the scope, which is much like compile but indicates you expect the JDK or a container to provide it at runtime. It is only available on the compilation and test class path. Test class path is used for your unit testing like JUnit test cases. Third type of scope is runtime. This scope indicates that the dependency is not required for compilation but is for execution. It is on the runtime and test class paths, but not the compile class paths. Test class paths are used during unit testing, as mentioned earlier. Then we have the test scope. This indicates that the dependency is not required for normal use of the application and is only available for the test compilation and execution phases. It is not transitive. Finally, we have the system scope. This is similar to provided scope, except that you have to provide the jar which contains it explicitly. The artifact is always available because you are specifying it explicitly and is not looked up in a repository. Now, after covering the dependencies, I am moving over to the elements for build settings. This element handles things like declaring your project's directory structure and managing plugins. Now coming over to build plugins. Build plugins are used to insert extra goals into a build phase. If you need to perform a set of actions for your project which are not covered by the standard Maven build phases and goals, you can add a plugin to the POM file. Maven has some standard plugins you can use. Example, the Apache Tomcat Maven plugin, which provides goals to manipulate war projects within the Tomcat servlet container. Now coming to environment settings. This is a feature of the POM to change settings depending on the environment where it is being built. For example, a project can be built using JDK 1.8 or any other JDK version. using different profiles. Now let me go to Eclipse IDE and demonstrate creating a Maven project that I will be using to code our web services. So here, as we can see that I have opened a blank Eclipse workspace with nothing here, and in this workspace I am going to create all my web services as a Maven project in Eclipse. So I click File, then New, and then Other, and search for a Maven project, select it, and Next. Now I don't have to select a archetype, because archetype is a templating toolkit, Maven templating toolkit, and I decide that I don't need a template. I will be creating everything myself, and then click Next. Here I specify the group ID as com.startupcentral. Then give the artifact ID a name of the central service. This will be the artifact. The name of the artifact ID that I provide here will be the name of the Eclipse project, as we will see as soon as we get out of this wizard. And then I select the packaging type as var, then give the name of the project the same as the artifact ID, and then click Finish. So now we see here a project is created and the name is the same as that we provided in the artifact ID. Then I go to the properties. So now I have to make sure that we are using Java 8 for building our project. So I go to the properties of the project and then select Java build path. And here we see that currently it's using Java 1.5 and we need to change it to Java 1.8. I go to libraries and change it to use the workspace default JRE, which is JDK 1.8, and finish. Now I need to go to make sure that during compilation Eclipse is using Java 1.8. So I go to Java compiler settings and change from 1.5 to 1.8. Let us look at pom.xml for this project. So as we can see here, the values that we provided for group ID, artifact ID, packaging as var, all being populated in pom.xml. So now to save time, I am not uh, going to demo creating each element within pom.xml during this live demo, but I am copying it from what I have created and putting it here, and I'm going to explain you the different elements of pom.xml for this project. So now we have the pom.xml for the web services project, and so this is the properties element that we see here. So as you might know that properties are like a key value pair, and you can use the values that you provide here by using a dollar and then the property name, and the property name should be in braces. So I will show you how to use it here in this pom.xml. So as you can see here, I am having the versions of different libraries that I am using, adding them in pom.xml as properties. So like Apache CXF version 3.2.1 and others as well similarly. Now we have the dependencies element, and as you already know now after the Maven lesson, or maybe from your prior experience, that these are the different that our project will be using. It needs there, and the beauty of Maven is that if it doesn't exist in your local repository, it will download from a central repository over the internet. And if there are any of those dependencies that leverage other dependency libraries that are so Maven is going to download that dependency as well. So here I have because we will be using CXF framework to create our web services, I am adding a dependency for CXF. And yeah, here you see that I am using the properties that we declared earlier, like apache.cxf.version with a dollar prefix to get the value in this tag of version. Then we are going to use Spring to configure CXF. So I need to add the dependency for Spring framework and Spring libraries. So that's what I have done here. Then I am using WS4J for security. So I am adding this WS4J library, and I am using Jackson. It's a very powerful API for marshalling and unmarshalling Java objects. Here I am declaring Apache Tomcat as a plugin. We will be deploying our web service within Tomcat, which is a web container. And here's the plugin to generate web service code from WSDL. So, there are two approaches that we discussed earlier: code first approach and contract first approach. Right. So, as you know that for contract first approach we need the WSDL to be there, and then from WSDL we can generate the classes required for the web services. So this library will be helping generate those Java classes and from the WSDL. So by default the CodeGen plugin follows the Maven convention of target/generated sources/cxf for the output folder for the generated classes. The options you can use to control the code generation Complete list of options can be found on Apache CXF site. -impl generates a starting point code for an implementation object. As you can see here, currently I have commented this plugin out because to start with I am going to use code first approach, and when we are done with that and we have the WSDL, I'm going to use that WSDL to demonstrate to you how to generate Java classes using this plugin. And at that point of time, I'm going to uncomment this section here. So now let me show you the structure, the folder structure that we get when we created the default Maven project. So it created these folders for us: Java, resources, and web app. And the test folder and the target folder. The target folder will hold all our artifacts or the compiled classes when we run our builds. So what I'm doing right now is within the web app folder, I'm going to create the deployment descriptor file, as the web service will need to exist as a web app and running as a web app in a web container, which is going to be Tomcat in our case. So I'm going to create the deployment descriptor, and it should exist within the web app folder, web folder, which will be in under the web app folder. So I go to new file and then give it a name of web.xml and finish. Okay, so I add the web app root element, and at this point I'll just create this blank web.xml. And then we will add further elements to configure CXF using Spring. So folks, now we have our Maven project set up in Eclipse to proceed with creating web service using Apache CXF framework. And I will demonstrate developing that in my next lecture. So folks, bye for now and look forward to see you there. Stay tuned.